Morning, everyone will be starting shortly.
Hi everyone. Want to welcome you to this live webinar, and we trust you are doing great. Welcome to day 4 of our Global Math Summit, and I'm here with Mr. Michael. I'm going to be doing some math problem. We'll continue from where we stopped during the live stream yesterday. Mr. Michael, hi.
Yeah, thank you very much, Mr. Chinonso, and thank you, participants, for joining today. Today we'll continue from where we stopped. Yesterday, we were able to solve some of this question in this section on the screen, and I think we are going to move on to the next section from here. So, Mr. Chinonso, we'll continue from this section. Yeah, please go ahead, sir.
Yeah, thank you so much, Mr. Michael. It has been an awesome moment. We've been solving a lot of math problems, and our students and participants have been enjoying it. We're so excited to solve math problem here and then to share our stories. And we trust that every individual should be able to share their own stories, the challenges they face with math, because math is to be enjoyed. Anybody can excel in mathematics, and that is the aim of these summits. This is day 4, and we're excited to get to this point of this particular webinar. So at this point, we're going to dive into the math problem, as Mr. Michael has said. We're going to solve these questions. We have question 33 through 42, which talks about writing the point slope form of the equation of a line that passes through a given point. So when you're giving points, you want to write the point slope form. So you recall from our webinar yesterday, the point slope form is given by y minus y1 is equal to m x minus x1. So this gives us the idea of the point slope form. So what we need, of course, we need the coordinate of 2 points, and also we also need the slope. So given 2 coordinates, we can always get the slope. So I'm going to solve question 33. So in question 33, we are given 2 points. That's the coordinate of 2 points. So we have -4 and 3. So let's see, that is our point 1. And then our point 2, we have -3, 1. So in getting the slope, recall that the formula for slope is y2 minus y1 all over x2 minus x1. So this is m is equal to d. So we want to get the slope. So our y2 here is 1. Our y1 is 3. So we can go on to substitute accordingly. So it therefore means that our m is equal to, so we have 1 minus 3 all over. So the, what is x2? x2 is the x coordinate of point 2, which is -3. So -3 minus, so what is x1, which is the x coordinate of point 1, which is -4. So we can go on to compute the value. So that's 1 minus 3, which is -2 all over. Now we have 3 minus, so this is minus times minus, which becomes positive. So that is -3 plus 4, which is 1. So our slope is -2. So by that, we've been able to get the slope, which is our m in the point slope form of the equation. So we just need to, at this point, substitute values. So that would be, so our y, we have y minus, so what is our y1? Our y1 is 3. So we have 3 is equal to, remember our slope, we found our slope to be -2. So that's -2. Then we open a bracket, we have x, then minus our x1, which is -4. So we have a -4 here. Then we can go on to simplify further. That becomes y minus 3 is equal to -2. Now, the only thing I'm simplifying is to distribute this -4 just in front of here. So it becomes positive. So that's x plus 4. So this is the point slope form of the equation. So we do not need to go solve further. I know, like I said yesterday, some students might be tempted to want to go further to solve it, but this is just perfect. This is the point slope form. Remember, this is the general point slope form of the equation. So you want to create an equation that looks just like it, and that is what we have done here. So thank you so much. Mr. Michael, over to you. The next question we can handle.
Yeah, thank you very much, Mr. Chinonso, for that one. And I'm sure. Yeah, thank you very much, Mr. Chinonso, for helping us solve question 33. So for those of us who are joining us live on YouTube, this is what we do every single day. What you need to do from here is just to subscribe to the channel, put the notification bell on so that every time we go live, you'll be the very first person to be notified. And if you're joining with us here live on Zoom, you're welcome. And maybe in an hour time, we'll give you the access to ask your question and we'll see how we can help you on the live section. All right, so I'll just do one more problem in this section, and I think that will be all for this particular section. So which one now do I solve? Okay, let's do question 40. Let's do question 40. So this is question 40. We want to find, the question is saying we should write the point slope form of the equation of the line passing through the given point. So we have these 2 points. We can call this one point A and we can call this point B. And just like Mr. Chinoso already explained, if you want to write this, if you want to write the point slope form of an equation, this is the formula. We have y minus y1. And that is equal to m in bracket x minus x1. So, and the m here represent the slope. Like we already discussed how to find the slope of a line. The slope is simply the change in y over the change in x, and that is y2 minus y1 upon x2 minus x1. So I think the very first thing I need to do is to just get the slope. So if I call here x1, okay, sorry, 1 second. If I call here x1 and I call this point y1, and here is x2 and here is y2, like I said earlier in the webinar yesterday, I said you cannot have x1 and y2 in a point because x1 is what give rise to y1, okay? The input x1 is what give rise to the output y1. So that's how it's going to be x1, y1, and x2, y2. So now you know the point. I think it's now much easier to get the slope. You just put in the values accordingly and you simplify. You get the slope, right? So now let's put in the values accordingly. So we have y2 to be 0 and y1 to be minus 4. So that would be 0 minus minus 4. If you observe, we have in minus on 4 on y1. Then the x2 is minus 5 and minus the x1 is minus 1 again. So when you have 2 signs just side by side to each other, you want to first of all simplify them before you start doing any further simplification. So the minus minus, negative times negative will always give us positive. So on the numerator, we have 0 plus 4. And on the denominator, we have minus 5 plus 1. And that is going to sum up to 4 over negative 4, right? Yeah. And that will result to negative 1. So the slope is just negative 1. So we've gotten the slope, and now we want to write this equation in the point slope form. We just put in all the stuff we got into the formula, and I think that is all we need to do. So we have y minus y1 equal to m in bracket x minus x1. So we put in the point y1. The point y1 is minus 4. So 1 second, sorry, my pen just went off. Yeah, I think it's back now. So we put in the point y1. The point y1 is negative 4. So we have negative 4 here. And the slope is negative 1. And x1 is negative 1. Again, you can use any of this point. I mean, any of this point. As far as the line is passing through them, it's no problem. You can use any of the point. And now you can see this equation is not looking very nice. So we need to clean up this equation to get to make it look proper. So we simplify the negative signs, and we have negative y plus 4, and we have minus 1 in bracket. We have x plus 1. And from here, you can just leave your answer like this if you don't mind. You can leave your answer like this because this is just like the point intercepts form like we have here earlier. So you can leave your answer like this and you're good. Or possibly you can just have it to be like y plus 4 equal to negative x plus 1. I mean, this is fine. Yeah, this is fine. All right, over to you, Mr. Chinonso.
Yeah, thank you so much, Mr. Michael, for that's a wonderful one. So I think we can move to the next set of questions. So in order to solve more questions, because our students are eager to see us solve a lot of problem and cover more grounds, we'll just take probably one or two per set. So this is the next set of questions we've got here. And so in this case, we are asked to get or to write the slope-intercept form of the equation of the line that passed through the given points. It's very similar to the previous set of questions, but in this case, we're not dealing with the point slope form, but the slope-intercept form. And to do that, we need to recall what our slope-intercept form is, which is by now, most of our students, most of our participants should have known the slope-intercept form, which is y is equal to mx plus c. So in the point slope form, we can look at the equation and get the slope and then the coordinate of the points. But when we talk about the slope-intercept form, we can see as constants the slope and the y-intercept. So that's the importance of the slope-intercept form. So given 2 points, we can go on to get the slope-intercept form, or we can also as well get the point slope form. So in this particular set of questions, the task is to represent it in the slope-intercept form, which is given as y is equal to mx plus c. So again, we want to find the slope of each of the two given points. So let's take question 45. So we're going to work with question 45, and then maybe Mr. Michael will take another one, and then we'll be good with this particular set of questions. So the points here are, let me write it here. So we've got negative 5, 5. So this is our x1, this is our y1, and then we also have another point, which is 2, negative 3. So this is our x2, and then this is our y2. So remember that the formula for slope is m is equal to y2 minus y1 all over x2 minus x1. So we want to compute the slope first, so we could substitute it in the equation and get the value of c. So here, our y2 is 3. So we can substitute that. So equal to 3 minus, what's our y1? Our y1 is 5. Now all over, what's our x2? Our x2 in the given coordinates, we have 2. So that's 2 minus, and then our x1, which is negative 5. So in further simplifying this, we'll get 3 minus 5, which is negative 2 all over. Again, this is going to be negative multiplied by negative, which becomes positive. So that's 2 plus 5, which is 7. So the slope here is negative 2 all over 7. So I can substitute it in the equation. And because I have a 2 points already, I already have 2 points in this in this case, I can also pick one of the points. I can either pick points for point 1 or point 2, substitute the equivalent corresponding values of x and y to get c. So this is now the equation. This is y is equal to, my slope is negative 2 all over 7 multiplied by x plus c. So I want to get the value of c, and I have 2 options. I can pick point 1, use the corresponding value of x and y, substitute them in this equation to get c, or pick the coordinates of point 2. So I have the right or the liberty to select any of them. So for this particular case, I'm going to select the points, the coordinates of point 1. So the coordinate of point 1, the y coordinate is 5. So that's 5 is equal to negative 2 all over 7. And then the x coordinate is negative 5. And then plus c. So what this helps me do is I have only one unknown, which is the y-intercept and also the constant. So this becomes 5 is equal to -2 multiplied by -5. That becomes 10. So 10 over 7 plus c. So I can continue here now. So this is 5 is equal to 10 all over 7 plus c. So I want to isolate c. So to do that, I want to subtract 10 over 7 from both sides of this equation. So that becomes 5 minus 10 over 7 on the left-hand side, which is equal to c. And then so to fully solve this, I can just get you have a denominator here. And then this is going to, so what's the LCM? So that's 7. So 7 divided by 1, 7 multiplied by 5. That gives me 35. So 35 minus 7 divided by 7 is 1. 1 multiplied by 10, which is 10. So it's equal to C. So I can go further to say 35 minus 10, which is 25. So that becomes 25 all over 7 is equal to C. So the value of C is 25 all over 7. So I can go on to compute that. So my slope-intercept form, therefore, would be Y is equal to -2 all over -2x all over 7. So the value of Y, which is 25 all over 7. So this is the slope-intercept form of that equation. Thank you so much. So Mr. Michael, over to you at this time. One more.
Yeah, thank you very much, Mr. Chinonso. That was very, very clear. I will be solving this same problem. Maybe it's one other question in this section, and I will use the slope-intercept form to get this. The point-intercept form to get the slope-intercept form. We can just work it out from that point. So let's get to work so you see what I'm talking about. Okay, so I'll do question, which one now do I solve? I will do question, sorry, 1 minute. Okay, so let's do question 44. Okay, let's do question 44, and that will be all on this section. So we want to find the slope-intercept form of the equation of the line passing through the given point. These are the points given to us. So we can just call this point A, and we'll call this one point B. So if this is point A, we can say this is x1 and this is y1, and here on point B, we can say this is x2 and the other one is y2. So, and now the slope-intercept form, just like Mr. Chinonso showed us earlier, this is the form, it's written in the form y equal to mx plus c. The m represents the slope or the gradient, while the c represents the y-intercept. The point where the line crosses the y-axis is called the y-intercept. So we want to see how we can write the slope-intercept form for these given 2 points. All right, so how do we go about it? The very first thing we need to do is to get the slope. Let's get the slope. The slope is simply the change in y over the change in x. So we have y2 minus y1 over x2 minus x1. And like you already see them, the coordinates are right there. You can see the x1 and the y1. All we need to do, just pick up the values for y2 for all these variables and plug into this formula and get the slope. So y2 is -2 and y1 is -1. That would be -2 minus -1. And x2 is 5 and x1 is -5. So that would be 5 minus -5. Now, moving forward, we want to clean up the signs right next to each other. So we have on the numerator -2 plus 1. And on the denominator, we have 5 plus 5. And that will give us -1 plus 10. So the slope is -1 over 10. So we've gotten the slope, right? So that is one thing we need to do. And the next thing we need to do, we can now write the point-intercept form of this line as y minus y1 equal to m into x minus x1. Okay, So we already see the x1 and the y1. We just plug it right here. So we have the y1 here is -1, and the slope is -1/10, and we have x1 is -5, right? -5. So now we just do some cleanup here. So negative becomes positive, and we have -1/10. In brackets, we're going to be having x plus 5. You all know how I got the x plus 5. The negative times negative will give us positive, right? Now, because we want to put it in the slope-intercept form, we need to now simplify this one much further. So I'll distribute with the -1/10, and so I'll be having y plus 1 is equal to -x/10. And when you distribute -1 by 5, you'll be having -1/2. See what is happening. So just like you have -1/10 multiplied by 5. The 5 here is 1. 5 divided 10 is 2. So that's how we got the -1/2. So moving forward from here, I can subtract 1 from both sides of the equation. So on the left-hand side, I have just y all by itself. And on the right-hand side, I'm having -x/10. Then minus half. Sorry, my pen just went off again. Okay, so I think it's back now. So minus half minus 1, that's going to be -3/2. Okay, minus half minus 1. Minus 1 is the same as, there's a trick in solving this kind of problem. -1 itself is the same as 2/2. So I just put 2/2 here. Okay, now they have the same denominator. We can just do -3/2. So -1 half minus 1 is the same as -3/2. So this is the slope-intercept form. You can see the slope is -1/10, and the y-intercept is -3/2. So thank you very much, Mr. Chinos. Over to you.
Yeah, thank you so much, Mr. Michael, for showing the participant this other perspective, which is a lot easier. Thank you so much. So I think we can move to the next set of questions.
Okay, now we'll be moving on to parallel and perpendicular lines. So I'll just move on straight to the practice section, and we start doing some practice. Yeah.
All right, thank you so much, Mr. Michael. So before we begin, we'd love to explain a few concepts to our students. So when two lines, two linear equations are graphed, there are three possibilities when a system of linear equations are graphed on the Cartesian plane. So the first is they could intersect at one point, and in which case they have one solution. So the second case, this is case one. A second case is where the two lines are parallel lines. So they never meet. So this is the Cartesian plane. So you plot and have one line and then the other line where they are parallel lines. And in this case, both lines have the same slope, but they have different y-intercepts. So M1, so this is line 1, and this is line 2. So M1 equal to M2. But then the y-intercept, so our C1 not equal to C2. And so in this case, we understand something. Their slopes must be the same. So when two lines are parallel lines, they share the same slope. Their slopes are equal, but their y-intercepts are different. So the third case, let me just draw it here, is the case where the two lines appear to be identical. So in other words, the two lines overlap. So given we have one line, let me change my pen color and see if I can have another line overlap upon this first line. So somehow we've got two lines that overlap. And in the real sense of things, these two lines have the same slope and the same y-intercept. So M1 equal to M2 and C1 equal to C2. So this is a case where you have the lines being identical and the overlap. Well, I think we can have a fourth case, which is going to bring us to our next set here. So we have a fourth case where the two lines are perpendicular. So let me draw it here. This is case 4. Let's assume you have a line. Line 1 is at this. So this is line 1. And then you plot line 2, and it appears to be perpendicular such that they intersect at a right angle. Their slopes, the product of their slopes is a multiplicative inverse. So in other words, if the slope of line 1 is, say, 2, the slope of line 2 would be negative half. So that when you multiply the slopes of these two lines, you get negative 1. So two lines are perpendicular when the product of their slopes gives us a negative inverse. And these last two scenarios, so this one, case 2 and case 4 are important to solving this set of questions that we're going to be tackling in a moment. So Mr. Michael and I are going to solve a few of these questions. And then this skill, understanding this concept will help you to solve these kind of questions. So Mr. Michael, I think you can take one of the questions, and then I will take it up with one more.
Thank you very much for the explanation, Mr. Chino. So I think it's now really clear to us now. We now know what parallel lines are, and we also now know what perpendicular lines are. So I would just want to do a little bit of some talk here. When the lines are parallel, the slope are the same, okay? And when the lines are perpendicular, the product of their slope is -1. So have that in mind, because that's what we are going to be using here. So find the slope of the line parallel to each given line. So let's start with question 1. So we have this line. We have y equal to 2x plus 4. This is a line, right? And we are looking for the slope of another line that is parallel to this one. I'll say that again. We want to find the slope of another line that is parallel to this given line. This is a line. So we're looking for the slope of the other line that's parallel to it. Now, like we said, this is a line. And what is the slope of this line? If you compare this line with the general equation of a straight line, which is mx plus c, you're going to see that the slope of this line is 2. So the slope of this line is 2. So since the slope of this line is 2, the line that is parallel to this line will also have the same slope, because when the two lines are parallel, their slope are the same. So the slope of the other line that is parallel to this one is still going to be 2. So M2 is still going to be 2. Yeah, so that is about it. Yeah, thank you, Mr. Chino. So over to you.
Yeah, thank you so much, Mr. Michael. So for this set of questions, it's just like to understand the thing that goes on behind the scenes. So we can literally get the slope by just inspecting once we arrange it in the slope intercept form. So the next question I'm going to solve would be question, say 7. Well, 6, we have question 6, 7, and 8 that are not readily in the slope intercept form, where we need to change it from the standard form to the slope intercept form, and then compare the slope. So let's look at question 7, for example. So this is the equation. We have 7x plus y is equal to -2. So we cannot tell by just looking at this. Well, we can tell that the slope is -7, but some students may just think that 7 is the slope. No, you have to rearrange. You have to convert this standard form equation to the slope intercept form before you can compute. So to do that, what you want to do is you want to subtract 7x from both sides of the equation to set it into the slope intercept form. So once I subtract 7x from both sides, both the left-hand side and then the right-hand side, I would get the slope intercept form. So that leaves me with y is equal to -7x minus 2. So I have set this equation in the slope intercept form, and so therefore I can tell that the slope of the line that is parallel to this line would definitely be -7, given that the slope of this line is -7. And from definition and by the explanation that Mr. Michael gave us, when two lines are parallel, they have the same slope. So our solution is therefore -7. Very easy. Yeah, thank you so much, Mr. Michael. I think we can move to the next set of questions.
Yeah, I think this kind of problem is very easy, and I'm sure those of us who are watching, uh, you can concur to what we are saying that these questions are very easy. And if you're just joining us on YouTube, all you need to do to participate is you check the description of this video, and I think you'll see the Zoom link that will bring you right on the Zoom call. Okay, and also you want to subscribe to the channel and put on the notification bell so that every time we go live on YouTube or maybe on Facebook, you'll be the very first person to be notified. And again, we don't just want you to be watching, we need you also to engage, participate, ask questions, especially those of us who are on YouTube. Then for those of us on live with us on Zoom, after we are done with the in 30 minutes time, we're going to open the call so that you can be able to ask questions or communicate to us. All right, so that's about that one. Let's move on to the next section. So the next section is talking about the slope of a line that is perpendicular to the given line. So we start with question 9. Okay, maybe I'll do these first two questions, then Mr. Chino so will take another one. So let me start with question 10. I'll do question 9 after I'm done with question 10. Then Mr. Chino so can do one more. So we already talked about when two lines are perpendicular, right? The product of their slope is equal to -1, right? So if you know, let's say for example, if I have a line with the slope, let's say 2, for instance, then the slope of the other line that is perpendicular to this one is going to be -1/2. All you need to do is to just invert the 2. You know, this 2 is the same as 2/1, right? So when you invert it, you put a negative to it. That becomes -1/2. Now let's do another one. So if I have a line and it's having the slope, let's say 3/5, then what is the slope of the other line that is perpendicular to it? That will be, you invert it. So when you invert it, you have 5/3, and you put a negative to it. So you have -5/3. And lastly, if you now have the slope of a line to be -3/2, now you can see this one is having negative sign, right? So the slope of the other line that's perpendicular to this one, all you need to do is to first of all invert it, you get 2/3. And now when you put a negative to this negative, that becomes positive 2/3. So you see how easy it is to get the slope of the other line that's perpendicular to a given line. So with that understanding, let's solve question 10 first. So for question 10, you can just see clearly, just like Mr. Chino also said, from inspection, you can now see that the slope of this line is -1/2x, right? That is the slope of this line, right? So what is the slope of the other line that is perpendicular to it? Now, since the slope of this line is -1/2, right? What will be the slope of the other line that's perpendicular to it? All you need to do is to invert it so you get 2/1, which is the same as 2. And when you put a negative to this negative, that becomes +2. So the slope of the other line that is perpendicular to this one will be +2. All right, so I hope that one is clear. Now let's do question 9. Question 9 is quite different, right? Because we are not having it in this form, y = mx plus c. So this here, if you graph this line, okay, if you graph this line, let me just kind of sketch something. Just give me a minute. Let me sketch something. Yeah, perfect. So if I sketch this line, I know this is not the best drawing, right? But I believe you guys know what I'm doing. So this is the y-axis and here is the x-axis. So if you want to draw the line x = 3, somewhere here is 0, the place where the two axes intersect is the origin. Here is 1, here is 2, here is 3. So the line x = 3 will be, let me use a different color for that. It will be the vertical line that crosses up the points when x is 3. Okay, so this is the line when x is equal to 3. All right, so now what is the slope of this line? What is the slope of this line? The slope of this line is, since it's vertical, right? The slope of this line is undefined. But we're looking at the line that's perpendicular to it. The line that's perpendicular to this one will be purely an horizontal line, if you see what I mean. I'm sure this drawing is not looking very perfect, but you guys can relate to what I'm doing. The line that's perpendicular to this vertical line will be purely a what? an horizontal line. And what's the slope of an horizontal line? The slope of an horizontal line is 0. So the slope of the other line that's perpendicular to this will be 0, if you guys get what I am saying. I hope that is clear. So if you have question, you can put it on the comment section. Yeah. Thank you, Mr. Chinon. So over to you.
Yeah, thank you so much, Mr. Michael. That's quite impressive, and I think we've done justice to this set of questions, and we can move on to the next set. Yeah, because given the fact that when you have an equation with an undefined slope, it's vertical, so the slope of the line perpendicular would definitely be 0, which is a perfectly horizontal one, and I think we've answered that clearly. Yeah, thank you so much. And I think we've also, this next one, we say write the point slope form. I think we've done.
Yeah, I think we've done stuff like this before. So we just move on from here. Okay, let's see this one.
Write the slope intercept form of the equation. Okay. I think, okay, this time what they're asking is not just the slope intercept form, but is of the one described. So we're looking for a line that is parallel to what they have given. Oh, okay, I think it's slightly different. It's slightly different. Okay. So we are asked to get, so I think we can do a few here. So they say write the slope intercept form of the equation of the line described. So we want to see a line that passes through 4, -3 that is parallel to y is equal to -2x, say for example. So if we have, so what we can pick from this to answer this is that the slope of the line that passed through these 2 points is -2. So we have y is equal to -2, sorry. So that will be -2 x and then plus c. So we want to get the value of c. So because we already have the slope, because that line is said to be parallel to this equation. So the slopes are the same. So to get the y-intercept, all I need to do is to plug in these values. So the value of x and y in the equation. So when y is -3, of course, x is 4, so I can plug it here. So that will be -2, and then my value of x is 4, and then plus c. So I'm left with -3 is equal to -8 plus c. And then to get c, all I need to do is to add 8 to both sides. So that this is, so once I add 8 to both sides, I have 5 is equal to c. So c is equal to 5. So that equation would be y is equal to -2x plus 5. So this is the equation of the line described with this following information. It passes through the point 4, -3 and is parallel to this particular equation that is given. So that's the answer to question 33. Well, I think we can take one more, right, Michael?
Yeah. I think the one that has perpendicular, Mr. Chinonso have just talked about when the lines are parallel. Of course, you already know when 2 lines are parallel, their slope is going to be the same. Okay, so now we will take one question that has to do with the case when it is perpendicular, right? And I can see question 41 has that case when the lines are perpendicular. So we want to just write the slope intercept form. The slope intercept form again is described as, can be reported as y equal to mx plus c. Okay, so this is what we want to achieve. This is our mission. We want to get stuff like that look like this, right? And now the slope, the line is passing through the point 4, 3, and it's perpendicular to this line. Now, see the way I'm going to attempt this question. You know, when we are talking about point intercept form, the one when we have y minus y1 equal to m into x minus xy in brackets, right? Okay, this is the point intercept form. So all I need to know is to get the slope. Okay, I need to get the slope from this line that is perpendicular to it. So let's bring out the line. We have the line x plus y equal to -1. So if I put this in the slope-intercept form so that I can get the slope, because I just need to get the slope, and then I'll get the slope perpendicular to it. So from here, I have y equal to negative x, negative 1. Okay, so what's the slope here? You can see the slope here is just negative 1. So the slope of the other line I'm looking for will be the negative inverse of this, right? So that will become the slope of the other line will be 1. When you take the negative inverse of this, that will be 1, if you understand what we discussed earlier. So all I need to do here is to just put the slope of this one to be 1, okay? And then I'll put in the points. The point is the x1 and the y1. So this is the x1 and this is the y1. That will be 4, and here will be 3. Yeah, sorry. So here will be 3. Okay. Oh, sorry. My pen is just misbehaving today. Okay. So sorry. Yeah. So the y1 is 3 and x1 is 4. So all we need to do from here, we just distribute. Of course, when you have something multiplied by 1, is the same as just keeping that stuff without any simplification. So we have x minus 4. And for me, I will just add 3 to both sides like this. So I have y on the left-hand side, and I'm having x minus 1 on the right-hand side. So this is the slope-intercept form of the line that is passed through this point and is perpendicular to this other line. All right. Yeah. Thank you, Mr. Chinonso.
Yeah, thank you so much, Mr. Michael. Very interesting way to solve this kind of problem. Yeah, I think we can move on to the next set of questions at this time.
Okay.
So I think very soon we'll open the floor for our participants to interact with us, share if they have any story they want to share that relates with math or a challenge or any question. Let's have it interactive so we could move from there. And then if there are tutors on the call too, we'd love to hear their perspective. And then if there are students, please feel free to share with us your experiences learning math while we get the next set of questions.
Okay, so we'll be moving into the next chapter on this material, and that is chapter 3, and that's about inequality. So I'll just slide on to where we have practice questions. So here's the practice question, Mr. Chinonso.
All right, thank you so much. So for this set, they said we want to draw a graph for each inequality and give the interval notation. So take for example the first one. Well, I think the first one is already solved. So to draw that graph, what you want to do is you want to have the number line. And so this is -5. So I think that will be my reference point. So let's say we have let's say 0, 1, 2, and so -1, -2, -3, -4, -5, -6, -7. So it is given that n should be greater than -5. So so -5 is my point. So I want to have, in this case, we need to always differentiate between greater than and greater than or equal to. So for this case, when I'm dealing with just greater than, I want to use cycles. But if I'm looking at greater than or equal to, I'm going to use cycles that is completely shaded. So let's assume that this is the -5. It's at this point. So I'm going to have it this way. So I don't need to shade the inside because the point will not begin at 5. It's just going to be greater than 5. So I have an arrow that points anything greater than 5 to infinity. So the interval notation here would be -5, comma, now positive infinity, like a positive infinity. So, well, I don't need to write a positive infinity. I don't need to write positive there. So, but this is the notation here. So this is the interval notation. So take note of the difference between greater than or equal to and greater than, just greater than. So in this case, the range of values that will satisfy this particular question, 5 should not be included because it must be greater than 5, not greater than or equal to 5. But if it were greater than or equal to 5, then 5 is inclusive. So the solution begins at 5 and then till infinity. So that's the difference here. Yeah. So thank you so much. So Mr. Michael, I
Yeah.
think you can take one more.
Okay, yeah, thank you, Mr. Chinonso, for that explanation. Now, I think it's now so clear. We now understand what to do when we have just greater than and when we have greater than or equal to. That is very important. You see, they are not just the same thing. There's a significant difference between these two inequalities. And just before I take one question here and start solving, I want to quickly just show us a little bit about inequality, just a little bit stuff about inequality. If I have, let's say, x is greater than 2, Mr. Chinonso already said this. I just want to make us see it more clearer. Okay, so if x is an integer, okay, if x is an integer, don't mind this stuff I'm writing here. It means x is an element of z, and z represent integer. Yeah. So if x is an integer, okay, and x is greater than 2, so what are the possible values of x? Just like Mr. Chinonso have said, 2 is not included because x is bigger than 2. So what is that next number after 2? That number is 3, 4, 5, 6, 7, and so on. So these are the possible values of x when x is greater than 2, and x is an integer. Take note, and integers are just positive and negative whole numbers, right? Okay, so when we now have x is greater than or equal to 2, what are the possible values of x? So because x is greater than 2, or x can also be equal to 2, so the very first possible value of x is 2. 2 is inclusive, just like he said. So then you have 2, 3, 4, 5, and so on. So these are the range of values. These are the possible values of x that you can have. Inequality is very different from equality. You know, when you're solving inequality, you don't just have a specific answer. You have range of values. Okay, that's why we are dealing with number. And maybe in our next slides, we will talk about a little bit what different kinds of numbers so that you understand integers, whole numbers, natural numbers, rational numbers, and other ones, and what have you. So we'll discuss that maybe in our next live stream. So I want to take this question 5. Yeah, you can see we have 5 is greater than or equal to x. Naturally, I don't like to have the variable in this right hand side. I would want to bring it to the left hand side. Some people are good with this, but I don't like it this way. I'm not comfortable having the variable in the right hand side. So it makes sense to now bring the variable to the right hand side. But be careful. You don't want to just say x is greater than or equal to 5. It doesn't work like that. You know, for equality, you say 7 equal to x or x equal to 7. But for inequality, it's different. You have to be careful. So if 5 is bigger than x, bigger than or equal to x, it can also be written as x is less than or equal to 5. Okay, you see 5 is greater than or equal to x. 5 is actually bigger. Then that means x is less than or equal to x. I mean, if you want to rewrite it the other way around. Now I'm comfortable with this inequality. And what they ask us to do, they want us to draw the graph. So just like Mr. Chinonso have already showed us earlier, my drawing is just looking very nice today. Mr. Chinonso, do you observe? My drawing is just my drawing is looking very nice
Yeah.
today. I used to be a very good artist when I was still in high school, but I left drawing a long time. So hopefully I'll go back to it, and if I have the time.
Yeah,
So
you need to.
all right, yeah, I will try. I will try. So this is the number line. I'm sure every one of you know how the number line works, and it continues. Lines do not have end. I need to just deviate a little bit. This we have. Let's say this is case 1, and this is case 2. These two are not the same. This one, case 1 is a line segment, is a portion of the line, just like you cut a part of the line. While case 2 is a line. So this is a line and this is a line segment, just like a portion of the line. Okay, so that's why we always put these arrows to tell you that the line continues in both directions. So we want to now sketch when x is less than or equal to 5. So I'll go right on the point where I have 5. I'll draw this stuff that looks like this, and I'll shade it because it is less than or equal to. And when it's less than, it's going down. So the values that are less than or equal to 5 are going to be 4, 3, 2, 1, and so on, right? So these are the values. It continues in that direction. Okay, just like you see in this chart here, you can also do it like this. I mean, if you have 5 here, okay, this depends on x. Okay, you can do that stuff like that. You shade it, and you take in the line, okay, and you put it like this. So some materials use this style, and some is using this style. So it's just the same thing. Okay, thank you, Mr. Chino. So over to you.
Yeah, thank you so much. So the next thing is, I think we'll also give the interval notation, yeah, which is going to
Oh,
be,
yeah.
yeah. So you solve question 5, right? So that's going to
Yes, yes,
be, it's going to be
yeah,
negative infinity and 5.
yes.
So
Negative
what that
infinity.
shows is excellent.
Yeah. Again, just to add to what Mr. Chinonso is saying, we have different kinds of brackets when we are doing inequality. We have this one is usually called the open bracket, and this one is called the closed bracket. So when we have 5 included, we are going to use the closed bracket here to tell us 5 is included in this. But if it's just like when we have it like this, we have 5 just like this, and it's going like this, it's going to be an open bracket because 5 is not included. Okay, maybe we'll discuss this subsequently, but this is what we use to write a number. When it's part of the inequality, we want to use this closed bracket, and when it's not part of the inequality, we use the open bracket to express that interval notation. All right, so that's all. Thank you very much, Mr. Chinonso, for calling my attention back to it.
Yeah, and thank you. I solved the one that had to do with less than or greater than without being equal to, and so I was thinking I was still on that. So it's good that the
Yeah,
student notice the difference in the bracket and which each represent, like you just said, which is perfectly correct. Thank
yeah,
you so much. Yeah, so I think we can move to the next set of questions. Yeah, so we have, for example, from question 7, where we need to write the inequalities of the given graphs. So in this case, question 7, we already have the graph. What we want to do is to write the inequality that satisfies or represents this situation. So for the purpose of this workbook, when we have, so you can see the difference between the starting point in 7 and 8. So 7 is when it's, in this case, going to be less than, but in this 8 is going to be less than or equal to. So it's
yeah,
good we take note of that. So the equation to question 7 would be, of course, I can say x is less than -2. So what this means is any value of x can be I can pick any value of x that is less than 2. For example, -3, -4, -5 to negative infinity will satisfy this particular inequality. So this is the way of writing that. Yeah, thank you so much.
yeah. Thank you very much, Mr. Chinonso, for that one. That was really, really very insightful. So, just like Mr. Chinonso already explained how to do question 8, I feel like not doing it again because you guys already know what the answer would be if you're going to solve question 8. Just so that we make sure we cover all of these angles, let's do question 8. So, again, it's less than, it's going this direction, it's less than. And if it's going this direction, it is greater than. So we pick the number here, 1. So we have, uh, well, if we have the variable x here, that would have been nice so that we can say x is less than or equal to 1. Okay, so these are the two different brackets we have here, this one and this one. All right, thank you, Mr. Chino. So I think we are done with this very section.
Yeah, thank you so much, Michael.
All right, so move on to the next one, and let's see what the next one have for us. Okay, this one is about solving inequalities, graph each solution, and give interval notation. Okay, you want to go on this one, Mr. Chinaso?
All right, I'll gladly do that.
Okay.
So we've got a number of questions here, and let me pick question 13. Well, I'm looking for the one that has a negative number. The reason is Well, let me allow Mr. Michael explain that. So I would go with 13. There are basic operations our students should know that when you have an inequality and you either multiply through by a negative number or divide through by a negative number, you need to flip the inequality sign. So, but just for purpose of order, I'm going to solve question 13. And so we've got x divided by 11 is greater than or equal to 10. So I want to solve this inequality. I want to also graph the solution and give the interval. So to solve this, you treat inequalities like equations, except that, like I said, if you are multiplying through by a negative number or dividing through by a negative number, you need to flip the inequality sign. But in this case, I do not have any negative number. So I just want to multiply through this equation by 11 to make sure I eliminate this denominator. So I want x to stand alone. So I want to multiply both sides by 11. So that gives me, so this 11 cancels 11. So that's x is greater than or equal to 110. So the next thing you want to do, so of course we've already gotten the solution, so we've solved the inequality. So what we want to do is to graph the inequality. So this is, so I can have points, say 90, 100. Let me just use flat numbers just because of the nature of the numbers here. Then 110, and then maybe 120. So we're saying x is greater than or equal to 110. That's greater than or equal to 110. So it begins at this point. So I have my shaded cycle, and then it goes ahead. And then the interval notation here would be now, so I've got 110, comma, then infinity, positive infinity. And the reason I'm having this closed bracket is, of course, it's greater than or equal to, so I'm using this kind of bracket, as Mr. Michael had explained previously, which is very correct. All right. Thank you so much, Mr. Michael. I think you can walk us through one more from this set of questions.
Yeah, thank you very much, Mr. Chino. So thank you very much, Mr. Chino. So I'm going to take on a question that has the negative, just like Mr. Chino have explained. When you solve inequalities, you just have to be careful when you have negative, and when you're dealing with negative signs of the inequality, you have to be careful because it's going to flip the inequality signs. Okay, and then I'll talk a little bit about inequality, about the infinity that works together with the inequality, just very, very quickly, and then we start solving this problem. Now, if I have, for instance, if I have negative 2x is greater than 5, greater than 10, for instance, and of course, I want to get the value of x. Naturally, what I need to do here is to divide both sides by negative 2, right? So if I divide here by negative 2, and I divide this side also by negative 2, inequality will change from greater than to less than. But if it's greater than or equal to, it will change from greater than or equal to less than or equal to. Then you want to ask, why is inequality changing? Let me just show you quick why it is changing. I mean, there are three cases that will flip inequality, three possible cases. There could be more, but I think for middle school and high school, you're going to always see these three cases. Now, the first one is when you multiply both sides by negative number, the inequality will flip. When you divide both sides by negative number, the inequality will flip. And when you invert both sides, the inequality will also flip. Let me quickly show you why the inequality is even flipping. If I have 100 here and I have 1, it's very clear that 100 is greater than 1, right? 100 is really greater than 1. But when we now multiply both sides by negative 1, so that I have negative 100 in the left-hand side, and now I have negative 1 in the right-hand side. Is it still true that negative 100 is greater than negative 1? Is it still true? No. You see, negative 1 is not bigger than negative, negative 100 is not greater than negative 1. The multiplying both sides by negative actually cause a change on the inequality. You can now see that we have to flip the inequality to make sure this inequality holds or is true. So that becomes like this. Negative 100 is less than negative 1. So you see how this stuff is happening. And another one I want to show you real quick is this. Of course, 100 is greater than 1. Again, now, if 100 is same as 100 over 1, hope you guys all know that. Okay, now if we now kind of invert both sides, like if we take the reciprocal of both sides, so that we now have 1 over 100 here, and now we have 1 over 1. Is this still true? 1 over 100 is the same as 0.01, just to put it in decimal, and 1 over 1 is same as 1. Is it still true that 0.01 is greater than 1? Of course, it's not true. So when you invert the inequality, it also affects the signs. It also make it flip. So that's basically why the inequality are flipping. That's just on this note. Now let us solve question 21. Let's solve question 21. So we solve the inequality, then we'll grab the solution and give the interval notation. So let's solve question 21. So we have negative 47 is greater than or equal to 8 minus 5x. And naturally, you cannot remove 5x from 8. It's not possible. So we want to now combine like terms, right? We want to get rid of 8 from the right-hand side to the left-hand side. So I'm going to subtract 8 from both sides, right? Okay. Now, subtracting 8 from both sides does not affect the inequality, okay? It's only when you're multiplying both sides by negative or dividing both sides by negative. So subtracting 8 from both sides does not affect the inequality. So when you do that, you'll be having negative 5x in the right-hand side, and negative 47, negative 8 will give me, if I take 3 and put here, I'll get 50, then I have negative 55, right? Am I correct?
Yeah.
Thank you very much. Thank you, sir. So I have negative 55 is greater than or equal to negative 5s. Now, what do we do from here? We want to divide everybody by negative 5. Take note, you're dividing both sides by a negative number. The inequality has to flip. So we divide both sides by negative 5. So we have negative 55 divided by negative 5. And here we have negative 5x divided by negative 5. And just remember that the inequality will flip from greater than or equal to less than or equal to. Okay, so when you go ahead and cancel out, you have just x all by itself in the right hand side, and here you just have that is 11. And this can also be written as, if 11 is less than or equal to x, it also means that x is greater than or equal to 11. So now we have the solution to this inequality. Let's go ahead and graph it. Okay, so this inequality depends on x, right? So we have here to be to be 0 minus 1. Here is 1. Let me just do some continuation and put 11 right here and 12 like that. So on 11, we'll come right that point where we have 11 and we are greater than or equal to, right? So we want to shade, right? And it's greater than is going this direction. So this is the graph of that solution. And the next thing we want to do is to write its interval notation. Okay, so it's going to now be 11. You can see 11 is inclusive. So we use this bracket to show that it's inclusive. And it's going to the positive infinity. Okay, these sides are the positive number. So it's going to the positive infinity. And here is a negative infinity. So it's going to the positive infinity. And it's going to be an open bracket like this. The reason is because the infinity is not a fixed, it's not a number. It's just an assumption that this stuff continues. Now, the reason why we're using a closed bracket is to tell you that this is where the solution is starting from. Okay, this is like the starting point of the solution. Then when it's moving to infinity, infinity does not have an end. It's open. So it continues to move and move. So we cannot have it closed. So it's going to be an open bracket. And if it's the other way around, to the negative infinity, it's still going to be open. So that is about this one for this particular solution. I think we are good. Sachin, so over to you, sir.
Yeah. Thank you so much, Mr. Michael. So I think we can have open the floor for our participants to make comments, ask questions, and for those participating, watching us through YouTube, please feel free to drop your question in the comment section, and we'll be more than happy to respond to as many. So I'm going to allow the mic. I'm going to allow the mic for all our participants. So if you have a question, comment, or any objection at all, please, you can feel free to share with us while we plan to round up this particular webinar. Yeah, so thank you so much, Mr. Michael. It's been an awesome time solving math problems with you, and I trust that our students have been able to learn a couple of mathematical skills.
Yeah. Thank you, Mr. Chino. So I'm always happy to have you on the call. I mean, it's so very good to have you on the call, share your experience, how you solve math problem. It's really, really inspiring, and I'm sure those of us here on the call can testify to that. Thank you, Mr. Chino. So, and I think we have some of our team members on the call. We have Dr. Colin Gan on the call. Greetings, Dr. Collins.
Mhm.
Have Joshua. Joshua is on the call, and we have our admin staff, Sunday Eze, on the call. Mr. Sunday, you're welcome. Okay. I think Dr. Colin wants to say something. His mic is open.
Okay. Yes, I have comment. I attended the webinar yesterday, and now I attended the webinar today. I think it would be nice if you can apply, what you share about graphs or slope to real practical problems that the students may encounter daily. Because you spoke about it's being able to like slope can be used to use it to find speed in physics. It would be nice if you can show them how it works. Yeah, that would be good. Yes.
Yeah, thank you very much, Dr. Colin Gunn. Thank you for the contribution. Yeah, on the webinar yesterday, I think Mr. Eze asked a question. Mr. Chino, so I think you dropped from the call. So Mr. Eze asked a question like, what is the real application of slope? Okay, he was asking on behalf of some student I'll be watching. He was asking, what is the real application on slope? Then I said that you made an example earlier talking about how the change of velocity, I mean acceleration, these are the application of slope. Then I also talk about it. I also said that when an engineer wants to build a bridge, they have to be very careful. They have to understand the measure of slope. Of course, they don't want to build a bridge where cars cannot travel through it. Okay, if the slope is so high, I mean, if the magnitude of the slope is so high, such that anytime the car moves through it, the car has to somersault. That is wrong engineering, right? So they have to make sure they do a proper measurement of the slope before they build any bridge or before they build any flyover or any kind of construction, because those things are very important. Of course, in construction, basically, not just only on bridge, even building houses and the rest of them, you see them use some kind of devices. I think I can't remember the names, just to make sure that everything is in proper alignment, right? So that there's no kind of imbalance in the building. So these are real application of these smart problems we are doing in real life scenario. And there are so many of them, not just one, not just two, like what Dr. Gan is saying. There are so many application of these problems we are solving in the real life. Maybe we are going to do a webinar such that Mr. Chinoso will not just be solving math problem, we'll be talking about the real life application of this math problem we are solving, so that they see what they can achieve from this stuff they are learning, and they see the application even on finance and the rest of them. Yeah. So I remember I have a degree in maths. So I remember when I was in university, we did some financial mathematics. Dr. Colin is also a finance pro. So we did a little on finance mathematics, do some modelings, do some price actions and the rest of them. And I never understood all of these things until I started moving into the real market, and I see, yeah, this is the application, and it makes a lot of sense that way. So I think we are going to work on that and have a separate webinar to discuss the real life application of most of these problems we are doing.
Yeah. Thank you so much, Mr. Michael, and thank you so much, Dr. Colin Gan, for that wonderful one. Yeah, so I think before we wrap up today's webinar, maybe we could also talk about some of the applications of inequalities in real life. The first example that comes to mind is when, for example, I want to budget and then I want to go to the market. I have limited resources, and then I would say I want to ensure that no matter what I buy, I don't want to go above a budget. So, for example, I have 1,000 US dollars, and I want to buy two different items. Say I want to buy shoes, and I want to also buy say bags. And then I know the cost for a shoe, say 50,000, let's say $50, and the cost of a bag, say $80. So I want to know how many bags that I'm going to buy, just to make sure I stay within my budget. So what that means, I would say, so let's say shoes is for S. So I want to buy, so I'm going to say 50,000. That's $50 multiplied by the number of shoes, which is going to be S, plus the number of bags multiplied by the price, which is $80 B, should now, I must say it must be less than or equal to my budget, given that the price of a shoe is $50, the price of bag is $80. So it must be less than or equal to $1,000. So this is one practical example of inequalities. Then I can also think of speed limits. So definitely, if, for example, the road safety or whichever agency that manage traffic would give a speed limit, students should know how to manage that and how to express that. Then if I also give a range of age, I'm saying there's age restriction, maybe it should be less than nobody above a particular age should be accepted. And this also helps students form foundational knowledge if they want to go on in maybe programming, so they need these skills. So that's a wonderful question, Dr. Collingan. And I'm sure, like Mr. Michael mentioned, in one of our webinars, we'll just talk about application of math concepts so that students can enjoy it and know why they have to learn these concepts. Every math concept we teach helps them, apply it in real life. Sometimes we do not know how these things apply. When I was in secondary school, in high school, I did not really know the importance of the slope-intercept form until I had even left secondary school, got to the university. That was when I learned mathematical modeling, where you could use equations to model a situation. And so that's one of the things. So thank you so much, Dr. Collingan, for that wonderful observation. It's very much appreciated. Yeah, so thank you so much, Mr. Michael. I don't know if we have any further contribution from any of our participants at this time.
Yeah, thank you very much, Mr. Chinoso, for that example. I mean, that really make a lot of sense. And those of you who are preparing for the SAT, you're going to see some of these questions he has shared with us here on the SAT practice test. I mean, you're going to see a lot of them here, and you see the applications. So for those of us watching here on YouTube, you can go ahead and put in your question in the comment section, and we'll see how we can react to that before we end the live stream.
Right. Thank you so much, Mr. Michael.
Yeah. Okay.